Hello, A-level student. Hope you're doing fine. We are further introducing our chapter 1 and today we are looking at polynomials. What are polynomials anyway? Poly means many things, right? So if I have a function, maybe I can call it a x power n, whereby my a is a constant and n can be any positive integer. If a is a constant, n is any positive integer, maybe it's an equation or what, the n here in the polynomial is what we call the degree of the polynomial or the order of the polynomial. And now if we are to begin with the simplest polynomials, which are the quadratic polynomials, if we are dealing with the quadratic, I can simply say quadratics. Quadratics are simply polynomials of degree 2. Right, I know you did these ones in O-level and I don't want to go deep into the O-level stuff, but I want to borrow a concept from O-level that you guys did, which was the completing of squares in solving quadratic equations. So if I say solve the our question, I say solve the equation, I have the 2x squared minus 6x plus 4 is equal to 0. So it is such a simple one, but then how do we complete squares? So as part of our solution, I have here 2x squared minus 6x plus 4 is equal to 0. Completing squares requires that the coefficient here is a 1. So I can divide everything by 2, so that I have x squared minus 3x plus 2 is equal to 0. We can take this body the other side, x squared minus 3x is equal to negative 2. Basically, I've not been doing anything, so let's complete the squares. How do we complete the squares? Completing the squares requires that we have the coefficient of x, we square it and add it on both sides. Half the coefficient of x, square it and add it on both sides. So I have x squared minus 3x, then plus the halved coefficient of x, then I square it is equal to negative 2 plus the halved coefficient of x, then again squared, such that here I can resolve the squares, this and this, into one square. So that I have x minus, the minus here, maintain it, minus 3 out of 2. If there was a positive, I would maintain the plus. So I maintain the negative, so squared will equal to a negative 2 plus, I think, a 9 out of 4, such that mathematically I've not changed anything. This guy, when you expand it, it goes back here, such that I have x minus 3 out of 2, again this body is squared, is equal to, so that I say a quarter, because the LCM is a 4 times this guy, I say negative 8 plus 9, so it is a quarter. So I take the square root, so that my x minus 3 out of 2 is equal to the square root of a quarter. But I know that the square root of a real number is positive or minus, so this can go the other side. X will equal to 3 out of 2 plus or minus a half. So that my x is either equal to 3 out of 2 plus and a half, or my x is equal to a 3 out of 2 minus and a half. So you see here that my x is equal to 4 out of 2, which is a 2, or my x is equal to a 1. So it is such a simple algorithm. So allow me generalize this fact. So in general, if I have any quadratic equation, ax squared plus a bx plus a c, that is equal to 0, we said we make this one 1. So I have x squared plus a b out of a, x plus a c out of a is equal to 0. Let's see, still follow the same algorithm of completing squares. So I have x squared plus a b out of a, x will equal to negative c out of a. We said we are halving the coefficient of x, squaring it and adding it on both sides, x squared plus a b out of a, x, then plus the halved coefficient here, b out of 2a, this guy is squared, is equal to negative c out of a, plus the halved coefficient of x squared, this guy is squared. so that I resolve the squares into one square. So this guy disappears, I maintain this, so I have x plus b out of 2a. This guy is under 1 square. This will equal to the LCM here. Okay, it is negative c out of a plus a b squared divided by a 4a squared. The LCM is 4a squared, so x plus a b out of 2a, this guy is squared, will equal to the LCM, so this goes to 4ac negative plus a b squared out of 4a squared, such that if I bring this guy this side here and this side and I take the square root, my x plus a b out of 2a will equal to the square root of a b squared minus 4ac out of 4a squared. But this is positive for minus. I take this guy the other side, my x is equal to a negative b out of 2a, and then plus or minus, so the square root of this lower portion, because I can take square root here and here, will equal to, so I can maintain only the upper part, b squared minus 4ac with the square root sign divided by, this guy is twice a. The LCM can be maintained as 2a, so that I have my x is equal to a negative b plus or minus the square root of b squared minus 4ac divided by 2a. In other words, if I have any quadratic equation where I know the a, b, and c values, I can simply write this formula, then I get x1 and x2 direct here. So this is what they call, what you guys usually used to call in all over, the famous bulldozer. Yeah, so that is the famous bulldozer method. Yeah, so in our next video, let us see how now we evaluate the roots of quadratic equations. But otherwise, remember to subscribe to our channel, like these videos, then you can hit on the notification button so that every time we upload the new videos you are notified, and then you keep following up with the mathematics, because I think the mathematics is as simple as you see it on this